Hi everyone, today we're going to talk about section 12.1, probability events. So we have this warm up here. It says that Allie spins the spinner and draws one card without looking. So we've got a spinner over here and we've got some cards over here. She gets a 3 on the spinner and the 3 card, okay? Then she sets the card aside, spins again, and draws another card, okay? Is it possible for Allie to get a 3 on her second spin? So the first time she spun it and she got a 3, is it possible for her to get a 3 again? Okay, so with the spinner, okay, it is possible because we still keep the 3 on our spinner. It doesn't go away. So it is possible for us to spin, land on the 3, spin it again, and then land on the 3. Okay. Now, if she draws a 3 when she picks a card, and she puts that card away, okay, so let's say she got this 3 and then she put it to the side. Is it possible for her to get a 3 again? Well, the answer would be no, because she set the 3 aside. It's not an option anymore. Okay, so it's going to be not possible there. Okay. So how does getting a 3 card on her first draw affect the possibility of getting a 2 card on her second draw? So let's say she got a 3 for the first draw. Okay, and then she put that card away. It is possible for her to get a 2 on the second draw. Now, in terms of the likelihood, if we look at her first draw, she picked the 3. That was 1 card out of 4 possibilities. Now, if she takes that 3 away, so let's say we're covering up this 3, that's gone. She can also get a 2, there's 1 card there, but now there's only 3 possibilities. So what happened is the likelihood went up. We call that the probability. Increased. It's easier to draw a 2 the second time because there are fewer cards. Okay, so that's an introduction to what we call probability. And so probability is the likelihood of an event occurring, okay, or not occurring. So in order for us to determine probability, we first determine all the possibilities in a logical manner. This is what we call simple probability, where it's just one thing that we're looking at. So when you're figuring out those possibilities, we call that the sample space. You can either count or just find another easier logical way, and we'll look at a couple examples, okay? And then you want to figure out which are your winners. Winners are the outcome you're looking for, the outcome you want. So probability is the total number of winners divided by the total number of possibilities, okay? So let's say, for example, what is the probability? Let's do a simple one off to the side. Of rolling a 5 on a regular 6-sided die. Okay, a die is like one of those cubes that's got, you guys probably have used them in games, like board games. Okay, so each side has a different number. We've got 1, 2, 3, 4, 5, and 6. So the probability of rolling a 5, well, there's only one face of this die that has a 5 on it, but there are 6 total possibilities. Okay, so the probability of rolling a 5 on a regular 6-sided die would be a 1 out of 6. Okay, sometimes you'll see this written as a percentage. If you were to put it into your calculator, we've got 1 over 6, which is about 16.7%. Remember, when you have a decimal like this, you can move the decimal place over 2 units, and that gives us the percentage. So what if we have 2 die? So we have a red die and a blue die. Let me actually get a blue pen here. What is the probability that the sum of the dice will be greater than 8? Now we need to come up with our total list of possibilities. Now I could roll a blue one and a red one. That's one of our possibilities. I could roll a blue one and a red 2. I could roll a blue 1 and a red 3. And you guys can probably see the pattern in that, let's say I were to roll a 1 every time with the blue, there's 6 different possibilities with that red dice. Now what if I roll a 2? That's blue. I could roll a 1, a 2 and a 2, and so forth. And the same thing if we roll blue 3s, blue 4s, blue 5s, and blue 6s. Okay, so I'm just going to go through now and make all of those possibilities. All right, so you'll notice that if we were to count the total number of pairs, I have 6 pairs here, 6 columns here, so that gives me 36 total possibilities. Okay, so that's going to be in our denominator. Now we want to see how many winners do we have. We're looking for the sum of the dice to be greater than 8. So I want to look to see, okay, when do we have a sum that's bigger than 8? So either 9 or larger. So I'm just going to highlight, okay, some of these that add up to 9 or bigger. Now, 6 plus 2 is equal to 8. We don't want that. We want greater than 8. So I'm just going to go through and if you look at the rest of these, the sums are either 8 or smaller, okay? So if I were to count the total number, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. Now, when we have a probability, usually you want to reduce that as much as you can. So this fraction would get reduced to 5 over 18. Okay, now if we wanted a percentage, I'll have 27.8%. Remember that this symbol just means approximately equal to because we rounded. Okay. All right, our last one on this page. If one of the 4 points is picked at random, what is the probability that the point lies on the angle? Now, notice that we've got, and actually there should be one additional point. Somehow it didn't get printed, so let's put that over here. Let's call this point E. Okay, so we have 5 different possible points that we can choose from. So those are going to be, actually this should have said 5 as well. Let's go ahead and fix that. Okay, so if one of the 5 points, there we go, is picked at random, what is the probability that the point lies on the angle? So we have 5 possible options. Now, how many of them are on the angle? Well, the angle is this entire portion over here. It's not just the vertex, the whole angle is here. So I have 1, 2, 3, 4 of them on that angle. Okay, so these examples on this page are called simple probability. Okay, now today we're going to be talking about something a little bit more specific. If we flip to the next page, we're going to talk about the probability of mutually exclusive events. Okay, so let's say you roll a standard number cube, also known as a die. Again, that looks like a little cube. We've got 6 sides, or 6 faces. Each face has a number on it. So usually you'll see the little dots. We've got a 1, a 2, a 3, and then behind it you'll have the 4, the 5, and the 6. Okay, so you've got 1, 2, 3, 4, 5, and 6. Okay, so let E represent the event, roll an even number. Let T represent the event, roll a 3 or a 5. What is the probability that you roll an even number, or, that's a really important word, or you roll a 3 or a 5? Okay, so what we're going to do first is show the outcomes of events T, E, and T as a subset of the sample space below. So we call this the sample space, aka the possible outcomes. Okay, now remember that we said that E was rolling an even number. So I put 2, 4, and 6 into the even numbers because that would satisfy that requirement. T was rolling a 3 or a 5, so I put 3 and 5 over here as well. Okay, and 1, because remember that one of the sides of the dice, it has a 1 on it. So that's neither even nor is it part of 3 or 5. So we put it outside. We put it in, like, you know, outside of the 2 circles. Now we say that these events are mutually exclusive because there's no outcome in both sets. Notice that 2, 4, and 6, none of those are in T. 3 and 5, none of them are in E. One of the things you want to look for is you're going to say that there's no overlap of the events. Okay, now there are 5 outcomes that are either even numbers or a 3 or a 5. Okay, so and it's important to note that there are a total of 6 possible outcomes in the sample space. Okay, so notice that there are 3 possible outcomes in E and 2 possible outcomes in T. So if we're looking for the total number of possible outcomes, we've got 3 plus 2, we'll put that in the numerator, those are these successes, because we want the probability of something either in E or T, okay? So when I add these together, I have a couple different options. I can just add them up and say it's 5/6, okay? And that would be my probability with whatever percentage that is. Let's see, 5 divided by 6 is 83.3%. But it's important for us to note the second part. That's the same as adding 3 out of 6 plus 2 out of 6. Notice you're adding together the probability of E and the probability of T. So add the individual probabilities. So with even numbers, there are 3 even numbers in my list up here, 2, 4, and 6 out of 6 possibilities. Choosing 3 or 5, well, those are just 2 options out of the 6 total. So if I were to add these together, that would give me the probability of rolling an even number or a 3 or a 5. Okay, so let's do another one together before you try on your own. Okay, so same premise up here. So let E represent, oh, did I change this? This actually should have said an odd number. That was a mistake. I'll have this fixed on your notes packet before you guys even take these and watch the video. So you can ignore what I've got on here. Okay, let's do roll an odd number or roll a 2 or a 4. So what we want to do okay, and actually this word should say or. Okay. All right, so actually since this is really similar to the problem that we had up above, I'm gonna have you guys give it a try. Start by drawing the sample space just like how we did up above and see if you can find the probability. Okay, so go ahead and hit pause and we'll continue in a moment. All right, so you should have had something similar just with different numbers going on. So the probability of rolling an odd number is 3 out of 6. The probability of a 2 or a 4 is 2 out of 6. When I add them together, I get 5 out of 6. Now, the next question says, what is the probability that you do not roll an even number? That means it has to be an odd number. If it's not even, then it has to be odd. Well, if we look at our sample space, remember we've got 1, 2, 3, 4, 5, 6. Total is 6 possibilities, and 3 of them are odd numbers. Now reducing that fraction gives me 1/2 or 50%. Okay. All right, let's go ahead and flip to the next page. Okay. All right, a box contains 100 balls. 30 of the balls are purple and 10 are orange. Okay, so let's go ahead and start by creating our sample space, which I'm going to draw off to the side here. I like the visual representation. So we know that we've got purple. Okay, there's 30 in here. We have 10 orange. Okay, now if there are 100 total, well right now I've accounted for 40 of them. There must be 60 other balls in there. They must be a different color, okay? Now you'll see that the total sample space, total number of possibilities is 100, okay? So we want the probability that the ball is purple or orange. So we're gonna do the probability of purple. The notation we use is just a P, and then I could just write purple. And we're gonna add the probability that it's orange. So probability of purple, well, we've got 30 purple out of 100 plus 10 out of 100, because 10 orange. So we end up with 40 out of 100. Now we want to reduce our fraction. One quick way to do that, actually I'll show you by hand and I'll also show you in the calculator. When you have a 0 on top, 0 on bottom, they cancel. So we have 4 over 10. And now we can just divide each by 2. So we're reducing the fraction. So we have 2/5. Now the fraction we get, or the decimal that we get when we divide in our calculator, is 0.4. Okay, so that's 40% probability. Okay. Now in the calculator, if you had put the original fraction in, I'll show you guys a shortcut. If you do 40 divided by 100, that's 40%. If I wanted to write this as a fraction, I would hit math, and number 1 is frac. So notice it gives us 2/5. So you can go back and forth between a decimal and a fraction, okay? Now if the ball is not purple and not orange, it has to fall into this outer section. So that would be our 60 over 100, which is 60% or 3/5. And obviously you can put that into your calculator, okay? The last little bit here, so we've got a little summary box, and we talked about this first bullet point. The probability of A and B happening if mutually exclusive events. Notice we've got mutually exclusive because there's no overlap here. A is separate from B. Now, is it possible for something to be an A and an B at the same time? That's not possible. That's why we say that it's a 0 probability. So that's 0% or just the number 0. Okay. Our last bit is what we actually talked about with this not purple and not orange. This is called the complement. Okay. So if we started by saying the ball is purple or orange, okay, well, not purple and not orange, we would do 1 minus whatever percentage this was. So in this case, I could do 1 minus 2/5 or 1 minus 0.4 would be the same thing because those are equivalent fractions. And we end up with 0.6, okay? So we could look at the number of successes, or you can subtract the opposite basically from 1, okay? So let's say if I want the probability of the complement down here, so we want the probability of A not occurring, it would just be 1 minus the probability of A, okay? All right, so homework is posted. I know our schedule's changed slightly, so the homework is gonna be due Wednesday night, okay? All right, guys, have a great day.